Okay, I'm back again after solving that question just like a few minutes ago with this question. So this is also an easy question, so it should take me like 10-15 minutes if it is really easy. Okay, so given the root of binary tree, check whether it is a mirror of itself, symmetric around its center. Okay, so is this a mirror or not? 2 3 4 2 4 3. Not sure. So how is it mirror? Like, I think right will go to left and left will go to right, right? So then that way. This one around center, right? So in the center, this is not a mirror because this is exactly the same. If it was mirror, then it would have been something like 2 and then 3. 3 would have been on the left, right? If it was a mirror. So it means that whatever is the center, its left should be equal. Yeah, it should be equal, and its left child should be its right child, left child, right child, something like that, you know. Yeah. So these two should be same, and so if this is A and this is B, then symmetry around the center, it means this should be B and this should be A. And what about this one? What about this? Suppose they see D, E and F, then what would happen? I think it would be C, D, E, F, something like this, right? Because I want it to be a mirror of itself. Because if this is the mirror, then this way it will be like this. Yeah. I think it is more of a BFS kind of thing here. Because in the BFS, if I see that both recursive and iteratively, interesting. So recursively means DFS, and iteratively means BFS, right? I don't know why, but I think of BFS. I thought of BFS first here. But if I do BFS with, then how do I know which exactly is the center, you know? That is the biggest dilemma, I guess. So if I'm doing a BFS solution, then will I know if what is the center? So one is BFS and another is DFS, right? Solution. So in the BFS solution, how will I know which one is the center here? I mean, if all the nodes are equally distributed, right? If it is a complete binary tree, then I would have known. Like if there are 1 2 3 4 5 6 7 8 levels, then first 4 would be the left one from the center and right one from the center. But not always. Like if it is something like this, so the same tree, but if it was something like this, 1 2, and then suppose not B is not here, and so so in this case, suppose in this case, if it was BFS until then, if it was symmetric until level 2, and this level is also symmetric, but suppose this is the case, yeah, actually we can do BFS, I think, because if the upper level is symmetric, then it means that the lower level should also be uh, so what wherever the upper level ends, then it means this is a child. Yeah, every time. I mean, suppose this is the case. Okay, so suppose this one is not here, suppose it is just like this, then also I will know, right? Because the upper level, I would know that okay, AB is the first left, and then BA is the right. Then if I see this one and this one is not same, then I can just say. So yeah, for BFS, that is the, I think, approach. So for every label, when I go to every label, then I can just know, we can know which elements are on left side, which are on right side, right? And then once we know which are on left and which are on right side, we can just see if the reverse is true or not. If it is AB, then it should be BA, exactly the reverse, it should be exactly the reverse. So for example, in the beginning it will be 1, right? And then left child 2 and right child 2. Okay, so this will be left and this will be right in the beginning only, in my first level 1. And then next time, in next iteration, my left will be 2's children AB, and my right will be 2's children BA. So I'll just see if this is exactly reverse or not. If it is, then I will continue. So now my left will be these children, whatever A and B children are. So it is DC, right? And my right will also be B and A children, which is C, D, E and F. So I will see if these are exactly opposite or not. If it is, then I will look at other level. If it is not, then yeah, so that's how I will do. I will just keep 2Q all the time, and do the FS for left and right separately, and then see if it is palindrome, not palindrome, but if this one is exactly opposite or not, whatever it is, the right one. So to check if it is exactly opposite or not, what I can do is, either I can, because this will be a queue, right? This will be an array. So actually I can just change it into a string one way, that is one way, or instead of changing it to a string, yeah, I can do that. I can either uh, yeah, I can either change it into a string, or I can or there is another way, so whenever I do left, then I can just see if the right one starts from the left top, left last one or not. If it is C, okay fine. D, okay fine. Then E, okay, E is now here but it is not here, right? So I will just return false at the time, or I can just create a string on every time. So yeah, so suppose this was empty, okay, then it would be just D only. So this string will be D and then empty. So since it is D and empty, so in the beginning only it should be empty in the beginning here, and then something like that. Okay, yeah, so if this is the case, then it will be because this will be empty empty D and empty, and then this is empty D empty empty. So yeah, okay, let's look at the solution now. If my solution is right or not. Let's not look at the recursive, let's look at iterative. So iterative is BFS, and recursive, which, so how will we solve this using recursion? Recursion also similar way, I guess. 1, then 2, and then we will go to A and B, and this will go to 2 B and A. So while we are going to left and right, so whenever uh, its left is not equal to right, then it means that it is not a symmetric tree. Yeah, because this one's left should be this one's right, and again A's left should be B's right. Yeah, it is easier actually. This one is easier. So see, it's mirror. So yeah, this right should be equal to 2's left, right, and left should be equal to 2's right. Yeah, so this is that was DFS, and then BFS. For BFS, we can also use iteration with the aid of Q. Is two consecutive nodes in the queue could be equal, and the subtrees a mirror of each other. Initially queues contain root and root. Then the algorithm works similar to BFS with some key differences. Each time two nodes are extracted, their values are compared. Then the right and left children of the two nodes are inserted into the queue in opposite order. So I have 2 minutes left here in my timer, 2 minutes 43 seconds. I'll just look at the solution. Until then, I'm just looking at the solution. I'm just looking at the code, how they are doing it. Pushing left and right, right and left. So in the beginning it will be root and root. And why are they putting two roots there? Because then when I'm pushing it, then it will add the children so many times. It will add it 4 times. So that push will be 2 comma 2 comma 2 comma 2, because t1 and t2 are the same. It is the same node 1. So 2 will be inserted 4 times. And 2 and 2 will come up, and then 2's children will be inserted now. Two's left, two's right, t1's left, and t2's right. Yeah, I must say this solution, BFS solution, it is more complex than the DFS solution, because DFS, like, I just came up with myself just by looking at it, right? Because I can just go recursive solution, like going deeper, and then just check if left and right are equal or not. It is much more simpler. Yeah. Okay, everyone, thank you very much for watching. If anyone is watching, bye.